Welcome to our online pub. Please start.
Thanks. Can you see my screen?
A little bit late, but of course, Adi is with us. Hello, Adi. Can you hear us?
Hello.
And can you do
it? Yes, I'm opening the presentation, trying to share it.
Could you share your screen?
Okay. Can you see my screen now?
Yes, now we decided to our stage, so you can see now. Oh.
Sorry.
I added it on the side, but this is still black. I'm not sure if internet connection is okay because I use this one here from the comments. Let me maybe remove and delete. I hope it is visible now. Yeah, everything is all right. I can see permission planning, got to coach them all. So everything is all right. Yeah. So let me remove myself and the stage is yours. Good luck.
Great, thanks. Okay, so hi everyone, my name is Adi. I'm really excited to be in here and talk about one of my researches called permission panic. In this research, I researched the various application permissions in Entra-ID, and I tried to see if there are any dangerous leads in these applications. My research question was, can I use these permissions to attack the tenants? But first, let's start with a quick introduction. My name is Adi. I'm a security researcher in SEB Paris. My main focuses are Active Directory, Entra-ID, and also code reviews. What we will see in here today. First, we will review application and delegated permissions, and also talk about the differences between the two. Also, we will see some attack vectors, and we will see an attack I found called hidden consent grant, and also talk about detections and mitigations. We will not see today POCs for all the attacks, for all the permissions I will present, and also we will not review all the permissions I went through because of time limits. Also, we will not see attacks against the infrastructure of Entra-ID. We only see attacks against the tenant itself. In Enter ID, we have a lot of objects, users, groups, devices, and managed identities, and many more. But in this research, I mainly focused on applications that are basically the templates for the application, and they live in the tenant that they were created at, and service principals, which are the local instance of the applications in the current tenant. Let's talk about delegated permissions. Delegated permissions are application permissions that are used to act on behalf of a signed-in user. The user has to approve these permissions, and then the application act as if the user was doing the actions. We'll use this permission, for example, when we are using mailbox or trying to use the permissions of the user. On the other hand, we have application permissions, which are the permissions used by the application without the need of a specific user. In this research, I mainly focused on this type of permissions, but I also touched on delegated permissions, but just a little in hidden consent grant. Where can we see these permissions? When we enter ID, we should choose app registrations and then choose the desired application and API permission tab. Then we will see a table with all the permissions granted to the applications. You can see in here, first of all, the type of the permission, which in here it's delegated, but we may see application in there. And we can also see the names of the permissions and if they require admin consent. In case they are sensitive permissions, they will require admin consent in order to make them work. During the research, I've created an application and entered its secret to Postman and used it to send graph APIs to Enter ID and try to act as if the application got application permissions and try to launch the attacks. Let's start. This one is interesting. The first one called attack simulation read write all. Using attack simulation, we can test the users in the tenant. We can launch attack vectors and see how many users fell victim to these attacks. For example, we can send malicious files to the users and see how many users enter these files. So in this attack vector, I use the application to create phishing mails to the users. By default, Enter ID allows only pre-configured links in the phishing mails, links that are safe, but we can also create our own mails by giving it our own HTML code. So in this example, I just gave it my own URL, and you can also give it whatever URL you want, and it will lead the user to the malicious. As you can see in here, I use this permission to send malicious mail to the user, requesting him to reset his password, and when he will click on the link, he will enter the malicious page. This permission is called device local credential read all. This permission allows us to interact with labs in the devices. Labs is a feature in Windows that allows Windows to generate periodically passwords to local administrators in these devices. The passwords are random and they're unique and they should be long passwords. So in here, I've used a Graph API request that allowed me to see the credential granted to one of the local administrators in the device. As you can see, there's a field called password base 64, and I've got a password for the device. Great. Now our next permission is called device management RBAC, read write all. As its name implies, it allows us to manage Intune actions in the devices. So in here, I've used the malicious application having this permission to create a new package, a new role, having all the desired action I wanted. For example, in here, I've asked it to have role create, roles read, and then I assign it to one of the users. And as you can see in the UI, a package was created and it was granted to one of the users. Now he can manage the devices using Intune. Going forward, organization read write all. With this permission, we can manage the metadata of the organization, things like subscribed SKUs and tenant branding information. But what can be done with it? First, as you can see, we can change the way our login page looks like, which is not very interesting, but we can also change the links in this page. For example, in here, I've used a Graph API that allowed me to point the custom terms of use link to a malicious page. Or in here, the forgot my password link links me to some other URL, or in here. Great. This permission was not found by me. It appeared in a GitHub repository called Abuse Azure API Permissions. And using these two permissions, we could generate to ourselves temporary password and enter the system, the tenant, with the temporary password. This way, we could bypass the MFA authentication and just use single password to enter the tenant. Generate to myself, I've tried to enter my security info, enter the password I've got, and I could get in. And now we can just change the password for the user. Another method also appeared in the repository, allowed me to change one of the MFA factors of the user. For example, we could change the phone number or change the mail to the attacker's number or mail, and then we could request a password reset through the service of self-service password reset, by the way, only if it's enabled, and then we could basically enter our own password, and then we could log into the system. This way, we could also bypass the MFA authentication. By the way, this service, the self-service password reset, is not always activated, and in case it's not activated, we will have to use policy read-write authorization in order to activate this service. We can do more than phishing using these permissions. For example, using policy read-write condition access, we could create conditional access to block all the users, also global admins, from entering the tenant, which meaning GA shall not pass. So in here, I've created a new access conditional access, and then I've used a user, a global admin, in that try to enter the tenant. After a few minutes, he got a message saying that interaction required, and he was required to sign in again. When he tried to sign in, he just got into infinite loop that just told him to log in. When he entered his valid password, he just couldn't log in, and he tried again and again and again. He just couldn't get in. He was blocked from the tenant. Cross-tenant access. Cross-tenant is basically all about granting resources to other tenants. In here, the attacker will create his own tenant and then create a link to the victim's tenant and try to use the malicious application located in the victim's tenant to get initial access to the tenant. So in this permission, I've used a tenant called Contoso, and the victim's tenant is called MSFT, and it got a malicious application having this permission, the cross-tenant access. After setting the tenant in the attacker's side, the malicious application in the victim side should create a link to the tenants to the attacker's tenant. As you can see, I've used some parameters in here. For example, which users can be shared to which resources and what type of access I'm allowing. These are the changes that we can see in the UI that the Graph API made. Also, the synchronization object. And then the attacker can basically select which users he wants to share between his tenant and the other tenant, the victim's tenant. So in here, we can see that a user from the attacker's tenant was shared with the victim's tenant. In the victim's tenant in MSFT, we could see a user from external. Pay attention that in this attack vector, we could not change users in the attacker's tenant and then hope that we will see changes in the victim's tenant. So we could not, for example, grant a user in the attacker's tenant a role of global admin and then hope that in the victim's tenant he will be global admin, which is pretty much makes sense. Its twin is called multi-tenant access. With this permission, we could manage multiple tenants. For example, in that we have seen before, first the attacker created his own tenant and created a multi-tenant in his tenant, and he said that there is a other tenant called MSFT, the victim's tenant, and it will be connected to this tenant. Then the malicious application located in the victim's tenant just create a connection to the ID of the attacker's tenant. And again, the attacker can decide which users he want to share with the victim. And then as you can see, a user from the attacker's tenant, Adele, is shared with the victim's tenant. Also, pay attention that, in here, we can change the password of the user only from its source tenant. It's also important. But again, we use this attack vector to create initial access to the victim's tenant. Okay, remember the role management read-write directory permission that allowed us to allow the user to grant permissions to other user permissions or roles and to manage other users. This one is the same. It's less known, but it also allows us to request temporary grant of role and then also to approve this request. We can also use role management read-write exchange, which is used to assign exchange roles. Yeah, exchange got its own roles. Exchange roles to users. As you can see in here, I've used a Graph API to grant myself a role for no expiration. All you need to know is only the ID of the role. You can see it in the roles page in Entra. And then you will get the role. As you can see in here, I've got a user, the role of attribute assignment reader. Also, we have the privileged assigned schedule read-write Azure AD group, which it's pretty much the same, but we can, using this permission, add ourselves to different groups and also sometimes to own them. In order to approve the request, we should use privileged assigned schedule read-write Azure AD group or role management policy read-write directory or role management read-write directory. As you can see in here, I just attach myself to specific groups owners. Well, this permission is pretty much obvious. We can use this permission to just disable users. And we can also do this action to global admins. So in this case, I just disabled Adele. Using this permission, we can invite other users from external tenants or just users that are not members of specific tenant, and we can enable them to enter the tenant. This way we can launch initial access vector. By the way, we can also decide how the phishing mail will look like. So how the mail will look like. So we can change it so it will be a phishing mail, for example. Here is an example of a mail I've sent to a user. Oh, by the way, you can also send this mail to existing users in the tenant, and you can use it as a phishing against these users. Now let's talk about mails. Using mailbox setting read-write, we can basically create automatic replies messages that users will send once they get a mail. That's interesting because we can use this feature to create phishing mails that will be sent to all the users that talk with this user. So in this case, I've changed the user of Adele, and when I've tried to send her a mail, I asked her to do something in the servers, she just asked me to create a ticket and send me a link. But this link will reference me to will point to a malicious page. Also, we can create a redirect rule in Outlook that will copy all the mails arrive to the mailbox of specific user or all the users to the attacker. So in this case, my user, Adi, sent a mail to Diego, the victim, and then Diego will forward the mail to Alex, which is the attacker, for example, and then Alex can read all the messages that arrive to Diego, also sensitive messages, reset password messages, and invitation messages. Using mail sent, I'm also able to forward the mails arrive to users. I can also, in case I have the permission of mail read basic all, we can also read the mails arrive to a user without forwarding it to us. If we will not use this permission, we just see a big string which we cannot read. Okay, in here I've just used the Graph API, and then we can see that a mail that arrived to the user was forwarded to us as an attachment. Now, let's talk about hidden consent grant, but before diving to this attack, let's talk about illicit consent grant attack. In this attack, the attacker creates a malicious page and tricks the user, the victim, to enter this page and grant and approve a consent to an application. The application should look innocent, and then after he will approve this application, the attacker will get various of permissions approved by the victim. Then he can use these permissions to attack the users or the tenant and do whatever he can using the permissions in the consent. In this attack, the consent is visible, and the user, the victim, should manually approve the consent, which if a user see the consent, it may be suspicious to him. But in this attack, the attacker got an application with directory read write all, and he should create a malicious page linking to some application he also owned without any sensitive permissions. And then after the powerful, for example, user enter this link, he will see no consent because the application he is using is not using any sensitive permissions. And after that, the attacker will use his application that having the directory read write all to grant more delegated permissions to the application that its consent would just approve, and then it can get more capabilities in the tenant. Now let's see a POC. Okay, first we have a weak user, which is non-privileged. He's not member of any group. And we also have another user called privileged, which is basically a privileged user, and he's a member of global admins. The attacker also had two app registrations. One is this application it got no sensitive permissions, it's not interesting. The other one called Postman, and this application got the directory read write all, as you can see. Now, the attacker will first launch a server listening to data arriving from everywhere, and then will wait for a specific response. The attacker will trick a user for, in this example, it's global admin. So the attacker will trick the global admin to enter a malicious page, and the global admin will enter the link, enter his account, enter his password. This page is not malicious, of course. It's a page of Microsoft. And in the attacker server, we'll see JWT, the access token of this user. Now let's decode it to see what it contains. As you can see, the scope is not interesting, so we cannot do anything interesting with this access token. No interesting permissions. Then the attacker will use the application he's got with the directory read write all in order to add additional delegated permissions to the 365 app registration. First, it will check if there are any permissions granted to this application. He will see there is one. So first he must delete these grants before granting any new ones. So he's getting the ID of this grant. It's deleted, great. And then he's granting new permissions to the applications. As you can see in here, the attacker grants the 365 innocent app registration the following permissions: offline access, non-sensitive permissions, but also he grants it role management read-write directory. The fact that we are using the consent type of all principals means that the global admin will not get any other consent before the application get these permissions.